And thank you everyone for joining us today as we share more about our plans to advance a world-class semiconductor ecosystem in Europe. It's bigger than one or two fabs. This is a holistic investment strategy, and it will create a world-class chip ecosystem that spans all of Europe. Overall, we envision investing up to 80 billion euros in the EU over the next decade along the entire semiconductor value chain. We are planning a new R&D and design hub in France, and we are expanding capabilities in R&D, manufacturing, foundry services, and assessing state-of-the-art packaging technologies in Italy, Poland, and Spain.
One of the barriers to getting into quantum research is having the facilities to actually fabricate working qubit chips. Tunnel Falls actually leverages Intel's manufacturing infrastructure, so we're able to fabricate many working, very reliable, high-performing qubit chips. And we're going to ship these off to university groups across the country, removing that overhead for fabrication, allowing them to really focus on advancing their research in the field of quantum computing.
This campus is one of the few places where you can do the kind of quantum computing research in a high-volume manufacturing environment in the world. Intel produces 300 millimeter wafers full of qubits, and we only test a few of them because we test what we need to go fast. The Laboratory for Physical Sciences has built a research community focused on the hardest problems in qubit physics. And we can work together with them, get them working on our Tunnel Falls hardware and move faster together. Building a semiconductor qubit research group is a huge investment. There are a lot of people with good ideas that don't want to use a quantum computer in a cloud, but they also don't want to set up all the infrastructure that would be necessary to fabricate them. We can get our Tunnel Falls devices into the hands of that research group, broaden the community, and bring more people into the quantum computing workforce.
I'm excited about Tunnel Falls because it's really that pivotal point of number of qubits in a device where you have to start thinking about automation. You can't brute force the tune-up, and you have to really get the infrastructure in place that we might need for larger and larger systems. All of us are here because we think this type of physics is fun, but particularly in these devices, they are robust and reliable and flexible enough to investigate the physics that we care about.
Tunnel Falls is the new generation of spin qubit devices that we're fabricating, and it showcases our 12 spin qubit linear array. The significance is that it's helping us to validate the fabrication processes as well as the actual device physics before moving to more complex two-dimensional qubit architecture. Quantum computing will help us resolve problems that there is no other route to resolve using classical computers. It will help us in cryptography. It will help us in impact that we're going to have with quantum computing.